Okay, back to our practice test. So again, we're on page 1. We almost have the first page done. We'll do these 6 here, then we'll do the next 6 for the next video, and then we'll be ready to start on some other pages. So these I'm going to have you go through on your own. We've already talked about this one, how all 3 of these are the same, so that would be equivalent. This is kind of like just saying, is this equal to that? That's what you should think in your head. Are they equal? If they're not equal, circle different. If they are equal, obviously circle equivalent. And remember that equal means exactly the same. So keep that in mind, because there's one on here in particular that a lot of students miss, because they're like, well, if you round it, that's what it's equal to. Well, rounding isn't equivalent. Rounding is called approximate. Okay, so go through, shut off your video, do those 6, think through them carefully, make wise choices, and then come back and we'll grade them together. Okay, this one we already talked about in lesson 1. Nope, it was lesson 2. I told you when there's when there's a letter in front with no number, we can put a 1, so you can clearly see this is now 1/7 x, and so is it this. So they are both 1/7 x. That's just a different way to write it. So you could do that with 5/6 x and 5x over 6 as well. These are also equivalent because 5 and x are in the numerator, 6 is in the denominator. So it's the same thing here, because this number out here goes with the numerator because it's really x over 1. And when you multiply, 1 times x is x, 7 times 1 is 7. So whatever's out here, even with the bar, is actually in the numerator. So this one is indeed equivalent, as is this one. Now this one is not, because as I said, that x is in the numerator, not the denominator. So to make this one true, you would have to write 5x over 6. Now that would be true. But these two here are different. But if you did want to make it a true statement, you would just put the x in the numerator, and it makes a difference where it goes. So anything out here is really in the numerator. Now this is the one so many students miss, because they do 2 divided by 3 in their calculator and they get 0.66666666666, and they go, oh yeah, that's 0.67. No, it's not. This and that are not the same thing. That is approximately what 2/3 is equal to. This is exactly what 2/3 are equal to. So if we had these two, we'd say equivalent. But these two are not equivalent. Equivalent means exactly the same, and they're not. 2/3 is 0.66666666666. So these are different, but these two would be the same. So no rounding is allowed. That's why it's called a rounded answer. It's not an exact answer. And these, hopefully everybody knows that's different. 23 times a number and a number divided by 23 are not the same thing. What I do if I'm not sure is I'll put a number in. 23 times 1 is 23. 1 over 23 is not equal to 23. So anytime I'm like kind of debating, I'll put a number in and see if they give me the same number. Put 2 in. 23 times 2 is 46. Is 46 equal to 2 over 23? No. And these, hopefully everybody knows, are different. We can't switch the order on a multiplication or subtraction. So if this was the problem, it would also be different, just like division is. So subtraction and division order matters. Not in multiplication, not in addition, but subtraction and division, order matters. Okay, so we'll do the other 6 on our next video. So we are on page 10 of our notes. So these are solving problems using proportions. So students always tell me, oh my gosh, I have no idea how you knew that was a proportion. Well, usually the biggest hint is they repeat quantities. Value of a house, tax. Value of a house, tax. So anytime I see the quantities repeated, that's how I know it's a proportion. So this is the value of the house, this is the tax. This is the value of the house, what is the tax? So the first thing I have all my students do, no matter what level it is I have them write how they're going to set up the proportion. So value over tax. And you could have written tax over value, but what matters with proportions is that you're consistent. And so a lot of students think, oh, I just write it in the order of the problem, and they go 90,000 over 1,200 equals X over 112,500. Does not work that way. You will not get the right answer. And usually the problem does not give it to you in the order you need. So that's why we put that here. So when we set up our proportion, we know the value goes in top and their taxes go in the bottom. So value 90,000, tax 1,200. Value 112,500. What is the property tax? So that tells me that's going to be my X. And if you wanted to make your numbers a little bit smaller, you could cancel the same number of zeros here. You guys have the ability to use your calculator, so that's not such a big deal, but I like it. It just makes you have to rewrite the problem, so I'm not going to do it, but you could do that here. 2 zeros, and then you'd have 900 over 12. Numbers are a little bit smaller, but most students don't think to do that when they're solving these, so I won't do it that way. So this is 90,000 times X equals 1,200 times 112,500. So this is going to remain 90,000 times X. And on the test, it does say set up a proportion and solve. So don't just pick up your calculator and start doing calculations. Every problem needs work. This is your work step. Set up the proportion, and then this is your solving. So make sure you don't just pick up your calculator, because if you just give me an answer, I'm going to go, I have no idea where that answer came from. I cannot give you credit. And that's the same way when it's listed in the syllabus. Do not expect credit with incorrect work or missing work. So math is all about showing your work. So on this one, we have 1,200 times 112,500. Set that equal, and that gives us, put in our commas, comma, 135 million. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then last but not least, divide by 90,000, divide by 90,000. So don't clear your calculator, because you already have that number right there. So all you have to do to get your final answer is do divided by. So then it will say answer divided by, and you type in your 90,000. And that would be 1,500. And then on word problems, the last 2 points when I'm checking your work is or last point, I'm sorry, I didn't mean to say 2 points. Last point when I'm checking your work is that you have your answer labeled with the units and what it represents. So this is dollars because it's property tax, and then you just say tax. So I know you know what that stands for, because I will tell you one thing I can't stand is students who just do mindless math and they have no idea what they found. So every teacher that you encounter is either going to, one, make you do like I did, label your answers telling us that you know what you found, or two, many of them will have you write a full sentence. A $112,500 home will have a property tax of $1,500. And I like that too, but on a electronic test, it's kind of hard to do that. But just be ready for that, because that is something that happens a lot. Teachers will make you write a full sentence describing what you found. Okay, let's do example 5, and then I'll let you guys try 6. Okay, biologists catch, tag, and release 120 deer in a refuge. 2 weeks later, they observe a sample of 150 deer, 25 of which are tagged. So how many deer are in the refuge? So it took me a couple times to read this and understand this one when I first started teaching out of this textbook. So I'm looking, going, what are they comparing? Okay, so this is how many deer are tagged in the refuge. And that, I kind of just skipped over that, and that's why I got confused when I was reading it. So 120 deer are tagged, but I don't know how many deer are in the refuge. So you would go tagged over total. Because you can see that here, tagged total, that's the total in the sample. This is how many were tagged. So that gave me the idea of what I was comparing, tagged to the sample that they observed. So you could start with this one or start with that one. It doesn't matter as long as you're consistent. So here 120 are tagged, but we don't know how many are in the refuge, so we're going to call that X. And I think that's why it was confusing to me, because these were separated and I had to realize they go together. 120 tagged out of how many total? 25 tagged out of how many were observed? 150. So it's tagged over total, tagged over total. So this cross product gives me 25x, or 25 times x, and this cross product is 120 times 150. So 120 times 150, 18,000. So 25 times x equals 18,000. So again, keep that 18,000 in your calculator. Last step is divide both sides by 25. So then you don't have to retype it. Just hit divided by 25. Love this calculator. So now I have to describe. No. No. What is wrong with that? Okay, let's check the work, because that answer doesn't make sense. There's not 720 deer in the refuge. Yeah, I guess that does make sense. Okay, let me just see again. I'm going to check my work. So 120, or let's go to the 18,000. 18,000 divided by 25, 720. Okay, for some, I thought it said 72. Or maybe it did. I might have forgotten a 0, and I'm like, no, 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 not 72. But 720 makes sense. So 120 are tagged. There's a total of 720 in the refuge. From the sample, 25 were tagged out of 150. And so how I knew immediately that 72 doesn't work is there's a way to check these. So you put your 720 here, and when you have a proportion, they have to have equal ratios. So 25 times 6, so think of 6 quarters, is $1.50, right? So 25 times 6, 150, and 120 times 6 is 720. So that's how I knew when I saw that 72, no, 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 that can't be right. But then when I did it again, I saw that it was 720. And that makes sense. So their ratios have to be the same. Multiply the numerator by 6. Therefore, this one must be the same. And when you multiply 120 by 6, you get our answer. So this would be, and you can usually use this sentence to help you with your label, the last sentence, 720 deer are in the refuge. And you don't have to say every word. 720 deer in refuge. Okay. The next one is yours. So go ahead and turn off your video and come back when you're done with example 6. And we'll see how you did. Okay, let's check this one. So we have number of people in Jackson. To estimate the number of people in Jackson, population 50,000 who have a flu shot, 250 people are polled. Of those 250 people, 26 had a flu shot. So hopefully you can see it's a lot like this one. It's the number with the flu shot over the total. So flu shot, or we can just write shot over total. So this just helps us be consistent, so we put all the numbers in the correct place. Anytime someone misses one of these, which isn't very often, I always look and they don't have this. They just wrote the numbers in the order they saw it in the problem and solved. This is the key. So how many had the flu shot? So we know Jackson has a population of 50,000. And we want to estimate how many have the flu shot. So that's going to be our X. So then of the random study, 250 were the total. And 26 had the flu shot. But see how confusing it would be if you didn't have this over here reminding you how to set it up. So flu shot, that's what they're asking us. Estimate how many have a flu shot in this population of 50,000. So how many have a flu shot out of 50,000? 26 have a flu shot out of 250. So consistency is required. If you get the order mixed up, it's impossible to get the answer right. So going this way, we get 250 times X equals, and then going this way, we have 26 times 50,000. And you could see how hard this test would would be without a calculator. So make sure if you don't have one, you get one ASAP. You don't want your grade to suffer because you're sitting here doing all this math and then dividing that huge number by 250 when you could be doing it in 30 seconds on a calculator. So we have 26 times 50,000. So 50,000. And that gives us, oh, these big numbers. Looks like 1,300,000. So 5 zeros, 1, 2, 3, 4, 5. Yep. And then the last step, last two steps, solve for x, label your answer. So the opposite of times is divide. So with your 1,300,000 still in your calculator, just hit divided by 250. So out of that town of 50,000, 5,200 are going to have the flu shot. 5,200 will have the flu shot, approximately, of course. So out of 50,000 people in the town, that's how many will approximately have the flu shot based on the sample. And that's how they do polls. Like when there's presidents, they don't call everybody in the United States and find out. They call a random, non-biased sample, write down their results, and that's how they say, oh, they're 50-50 or they're 49-51, because they're not polling the whole world or the whole nation. They're just basing it off the sample they called, making sure they get people from every state, rural, city, you know, so they make sure it's very unbiased, and that's how they can predict. Just like this. Okay. This one is on the test. I love this one because it practices our translations and it practices solving proportions. So it accomplishes two goals for me: to see if you know how to write a proportion, and two, to see if you know how to solve a proportion. So 12 divided by, so it's just one of those straight translations. 12 divided by, sum means plus, x and 2. X is first, 2 is second. So you just do exactly what we did before, just a couple words at a time. 12 divided by, sum means plus, there's your and, x is in front of it, 2 is after it. Equals, so put an equal sign in, the quotient, so we know quotient means division. Quotient is one of our operating words, so we have to look for and, so we know what goes in the numerator, what goes in the denominator. So 4 is before the and, it goes in the numerator. Difference means subtraction, so x minus 2. So see what I mean? It accomplishes two goals for me. I look to see if you can do a translation, just like we did for those 2 pages in lesson 1, and then I can test you to see if you know how to solve a proportion. So after that, you just pick up from where we left off on the front page. 12 parentheses x minus 2, and remember the parentheses are not optional. 2 terms in multiplication must be in parentheses. Same way on the other side, 4 parentheses x plus 2. So that gives me 12x minus 24 equals 4x plus 8. I have this one in my 126 class on a test, and this one too. So not only will you see them in this class, you'll see them in the next class as well. Similar triangles you'll see a lot. Okay, so now we have x's need to move to the left, so do the opposite. Minus 4x minus 4x, and that gives me 8x minus 24 equals 8. So 12 minus 4 is 8x minus 24 equals 8. So I like to write it below so you see where it comes from too. And then all things without a variable need to move to the right, so do the opposite to bring that 24 over. Opposite of negative 24 plus 24. And we get 12, carrier 1, 32. Divide by 8, divide by 8, x is 4. And that one really doesn't need a label on it because it's just a number. So there you have it. X equals 4. Okay, I'm going to let you try the next one on your own. Like I said, you will see this in pretty much every class you take. There's always things with similar. So what I'm going to tell you about similar triangles, if you don't remember it from geometry in high school, is that they're proportional. So when I teach this in my 126 class, I tell them to use, so the exact verbiage that you learned in high school geometry is corresponding sides are proportional. So this side corresponds with this side. That means they're in the same location. And this side corresponds with this side. So there's two different ways you can do this. You can do left side to base equals left side to base, or you can do left over right equals left over right. Doesn't matter. But now you have the corresponding parts highlighted with their special colors, so you'll be able to tell if you've set it up correctly. Okay, so go ahead and try that one, and then turn the video back on, and we'll check it together in a couple minutes. So I like doing it this way. To me, it just makes sense. So this would be 12, the left side, over the base 9 equals x, the left side, over the base 15. So the similar colors have to be on the same side. So 12 and x are both in the numerator. 9 and 15 are both in the denominator. So 12 goes with 9, x goes with 15, keeping them in the same order. After that, it's a piece of cake. 9x equals 12 times 15, 144. I think it's 180, but let's just see. 12 times 15. Yep. So we get 9x equals 180. And then last, divide by 9. I guess we don't really need the calculator for that. 18 divided by 9 is 2. And then add a 0. 2, add a 0. And then last, remember all word problems need units. So in this case, I can see it's inches. And that's the last point for every problem when I check your work from your quizzes and tests. Have they labeled all the answers in their word problems? This is only one we really couldn't label. We could say x equals 4 is the number, but that's kind of obvious. So here we would just write 20. Okay, that's part 2 of lesson 4. Part 3 coming up in the next video.